Hello everyone, today we're going to solve a daily problem from LeetCode 2833, count symmetric integers. So here we're given two position integer, low and high. And our goal is an integer x which consists of 2 multiplied by n digits is symmetric if the sum of the first n digits of x is equal to the sum of the last n digits of x. A number with an odd number of digits are never symmetric. So we should return number of symmetric integers in the range low and high. Here we given an example of low 1 and high 100. And out is 9 because there's 9 symmetric integers between 1 and 100, like 11, 22, 33, 44, 55, 66, 77, 88, and 99. So the idea is that we should split it between and check two sides. If two sides are equal, then it's good. If not equal, we return false. So for example, in the second example, we clearly see like if we split in two, we will have like 1, 2, and 3 here. And here, for example, we also have 12 and 12. Here we have like 2, 1, and 2 and 1, the same here. So we can think about this as the story of mirror numbers. So imagine numbers live in world with a mirror, a magical mirror. So some numbers have specific properties. If they have an even number of digits like 2, 4, 6, 8, etc., you can place the magic mirror right in the middle and both sides will be equal. A number is called a mirror number, so it is symmetric. And when you put the mirror in the middle, the sum of digits you see on the left hand, the mirror and the right are exactly equal. And disregard, for example, any odd number, for example 1, 3, 5 digits cannot be counted because we cannot put a middle mirror in the middle because the middle already have a digit in it. So in our task, we need to find exactly two equal sides. For that, we will use close to brute force approach in finding. First of all, we will make our count equal to 0. Then we check if each number in the range and low. For that we will use for loop in range low and high plus 1. Next step, we will convert to string and we will get the number of digits. So we use num str equal stri should be converted to string, and then n will equal length of num str, so number of digits. For example, here we have like 1200 and other number of digits, and we will convert them here, so we know it's 4 digits. After that, we will make prerequisite check. So for example, if they're not equal, so if they're odd, then we will skip it because it's impossible to work with odd numbers as we cannot place them in the middle. So if n modulo of 2 isn't equal to 0, then we just skip it using continue method. Then we need to get of each side. It will be equal half of n. And next step, we will calculate left sum and right sum to compare them. So for that, we will use left sum, which will be equal to sum of int digit for d in num str half len, then write sum will be equal sum of int digit for it in num str half len. Now we can compare if they are equal. So left sum should be equal to right sum. And if it's true, our count will be incremented by 1. And lastly, we will return our count. So let's check it and submit. So the code is passed. It's pretty efficient in memory. So here we have augmented pattern of enumeration with brute force check. So we check each side to get to know exactly if it's equal. If they are equal, we increase count. If it's not equal, it's impossible, so we just skip it. All right, thank you for your attention and have a nice day.